Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In today's lecture, we'll be dealing with the fourth and the last mode of convergence, which will be convergence in law or distribution. So, let us talk about what is the fourth law of convergence. From the name itself, convergence in law, or this is also stated as convergence in distribution. Here we are talking about the cumulative distribution or the distribution function of a random variable x. Suppose we have a sequence of random variable xi's, which is represented like this. All of these xi's have the distribution function. So here I am denoting the distribution function as f n x, where all n is greater than equal to 1. This is the sequence of the distributions of these random variable xn. Now if we have been given this, then we can say that this distribution converges to another distribution in x when these two situations are satisfied. That is, we can say that whenever we put limit n tends to infinity, then this distribution function, which is f n x, it always converges to f x x. It always converges in law or in distribution to this. Here one more situation is there, that it converges at all continuity points of x. This is our law of convergence in law or convergence in distribution. If we want to represent it, it can be represented by xn converges to x in law, or xn converges to x in distribution, which can be denoted by small d, or xn converges to x in capital D. Small d or capital D both are for convergence and distribution. We can represent this mode of convergence on any three of these things. Now moving forward to properties of law and convergence in law. So there are three main properties of this. First property is, if xn in law converges to x and yn in law converges to y, then there are three small things, two small things actually, which are xn plus yn will converge in law to x plus y, and xn into yn will converge into law to x into y. This is our first property of law of convergence. Now if we talk about the second property, so it is continuous mapping function. This we did in first law as well, mapping function theorem. So in this property, what happens is, if we have a sequence of random variable which is represented by this, and if we have a continuous random variable, let us suppose it is g dot, this is our continuous function. Right? So this is our continuous function, and we have xn in law converges to x. then we can estimate from this, or we can denote it from this, that the function of xn also converges in law to the function of x. This is our continuous mapping function theorem, where we have been given xn, which is a sequence of random variables, and g dot, which is a continuous function, and we have also been given that xn in law converges to x. Then we can say that the function of xn in law also converges to function of x. Now the third and the most important theorem of today will be, if it has been given to us that xn in probability converges to x, then from this we can denote that xn in law converges to x. So it only we only have to specify if it converges to x or not in probability. That means it will always converge in law if this is the case. And one more thing is there: if xn converges in almost surely to x, then this denote that xn converges in probability to x, and this will denote that xn converges in law to x. So in short, xn almost surely converges to x denote that xn converges in law to x. And in the previous lecture we did this, that if xn converges in rth mean to x, and if r is greater than 0, then from this we can denote that xn converges to x in probability, and from this we can denote that xn converges to x in law. So indirectly, xn and rth mean converges to x when r is greater than 0, then we can denote that xn in law also converges to x. So these are the relationships among all the others that we have seen, or all the mode of convergence. So let us make a diagram of this. Here, so here if we are saying that xn in probability converges to x, xn almost surely converges to x, xn xn in rth mean converges to x, and xn in law converges to x. These are the things. So we can say that if it is in xn converges to x in probability, then this directly denote that xn in law converges to probability. And from this also, if xn almost surely converges to x, then we can denote this as well, that it always converges to probability. And this can be directly indicated here as well, that if xn almost surely converges to x, then xn in law will also always converge to x. Now here, if xn in probability converges to x, then this can be stated that if r is greater than 0, then this also converges to in probability. And opposite, if all xi's are bounded, then we can say all the random variables are bounded, then we can say xn in probability if converges to x, then xn in rth mean will always converge to x. And here also xn and rth mean will converge to x is directly proportional to this. Then it can be said that here also r is greater than 0, that xn in law also converges to x. So this is our all the mode of convergences at one place, where each one is related with the other one, and here is how it is stated. So I hope that this diagram is clear, and if you haven't done the previous lectures on convergence, I would recommend you to see first them, then only you will be able to understand this diagram, otherwise you will not be able to understand. Now let us move to some questions for today. Here they have given us that xi's are independent random variables with uniform distribution. If yn is equals to maximum of xi and yn in law converges to z, then the limiting distribution of z is. So they have asked us the the distribution of z. First of all, they have provided us that xi's follow uniform distribution with the parameters 0 and theta. Now from here we can find that fx, PDF of fx is 1 upon b minus a, which is 1 upon theta minus 0, which is theta, for all x lies between 0 and theta. From here we can calculate the distribution function of x. If we have to calculate the distribution function of x, it will be integration with respect to x, and it will be x upon theta. This is simple integration, you can do it on your own. I'm just writing the direct answer, which is x upon theta. Now this can be written as probability that xn is less than equal to x, right? This is written as x upon theta, and this, first of all, we can write it as probability x upon theta. This is our equation number 1, let us suppose. Now they have asked us to calculate for yn, and yn is nothing but yn is equals to maximum of xi, x1, x2 up till xn. So maximum of xi, we can write it as probability that yn is less than equal to y will always be equal to probability that x1 is less than equal to y, x2 is less than equal to y, and so on up till xn is less than equal to y. But they have given us that all of these random variables are independently distributed. So instead of writing them differently, we can write it them like this, right? Now here they can also be written as summation from I goes from 1 to n probability that xi is less than equal to y. And this probability seems similar to this. So instead of this, we can write it as x upon theta, and here we can, instead of y, instead of x, we will be writing y upon theta. So y upon theta whole raised to the power n, because they are summing over n. So this is it, our probability. Now we have calculated this probability. Now and this can be written as f of yn y, right? This is the distribution function of the y's, or the maximum of all the xi's that has been provided to us. Now we have to put the limit here so as to check our convergence in law. So limit n reaches to infinity, f yn y is equals to, it is equals to limit n reaches to infinity y upon theta raised to the power n. Now here three cases arises. So let us see what are those three cases. I hope that you can see the above one. So let us see what are the three cases that arises here. The three cases that arises here. Case number 1, that y is less than theta. Case 2 is y is equals to theta. And case 3, that y is greater than theta. So when y is less than theta, from here when we put limit n tends to infinity, then this y upon theta is less than 1, because when we put it divided by theta on both the sides, it will be less than 1. So this limit, this are fyn y reaches to the limit 0 because it is less than 1. In the second case, when we put limit n reaches to infinity y upon theta, then this is equals to 1. So from here we can say that fyn y reaches to 1. And when y is greater than theta, we will put limit n tends to infinity y upon theta is reaches to is greater than 1. So from here it also reaches to the limit 1. And when we constitute all these three distribution function, we can say that it is nothing but f y y, because we have put the limit to n, we will not write it. So it has only two values, 1 or 0. 1 when y is greater than or equal to theta, and 0 is when y is less than theta. So this is our way. If we see that this is our degenerate variate, which is our option number B, and hence our limiting distribution of z is degenerate variate. So this is how you solve the question based on our law and convergence in law. Now moving forward to another of this kind of question only. Here they have provided us that xi's, all of the xi's follow uniform distribution, and they are IID, independent and identically distributed. Uniform distribution with parameters 0 and theta, and they have given us that x1 follows, x1 is equals to minimum of all the xi's. I am writing xi's here, x1 x2 up till xn. Now from here also we can say that the distribution function of x, the probability density function of x is 1 upon theta for all x lies between 0 and theta, and the distribution function of x is equals to x upon theta for all 0 lies with x lies between 0 and theta. Now from here we can say that they have asked us about x1, which is minimum of all the xi's, but this is the probability that xn is less than equal to x, which is the maximum. So if we have to calculate the probability of the minimum, then it will be probability that xn is greater than x will be 1 minus x upon theta. Now we have to calculate this probability. Probability that xn is greater than x can also be written as probability that x1 is greater than x into probability that x2 is greater than x, and so on, probability that xn is greater than x, right? But these are, as you know, identical and independently distributed, so instead of writing them like this, we can independently write them like this. And from here we can say that it is nothing but I goes from 1 to n, probability xi is greater than x. Now probability of xn is greater than x is 1 minus x by theta, and this will be equal to 1 minus x upon theta whole raised to the power n, because the n digits are multiplied like this. So here we have got this. Now they have asked us to calculate yn, which is equals to n x1. For this, we have to calculate that probability yn is less than equal to y. And from here, we can say that probability that n x1 is less than equal to y. From here, we can divide both the sides by n. We can write probability that x1 is less than equals to y by n. Since here you can see that for probability x greater than equal to x, it is 1 minus x upon theta raised to the power n. If we have to calculate that probability xn is less than equals to x, then this will be nothing but 1 minus x upon theta raised to the power n. And similar to this kind of equation, we have this kind of equation. So instead of putting n, we have to put y by n here instead of x. So let us put that here. So here putting probability that x1 is less than equals to y by n. Instead of x here, we will put y by n. Will be 1 minus x by theta will be y by n into theta raised to the power n. Now this is nothing but our probability distribution function of x1, or instead of x1 we can write it as yn, because yn is nothing but nx1. So probability function of y and y will be equal to 1 minus y upon n theta raised to the power n. From here we will put limit n tending to infinity f y n y, because we have to find the convergence in law of this. So we have to put the limit n tending to infinity. If we put limit n tending to infinity, so let us see what is the case of limit. If we put limit n tending to infinity to 1 minus y, or 1 minus a upon n raised to the power n, it will always go to e raised to the power minus a. Okay, this is the law of our limits. This is the law of limits chapter. When we put 1 minus a upon n raised to the power n, it always converges to e raised to the power minus a. Here a is nothing but equal to y upon theta. When we compare these two equations, a is reduces to 1 y by theta. So when we put limit here, it converges to 1 minus e raised to the power minus a, and a is y by theta, so it will reduce to minus y upon theta. And from here we can see that this is nothing but the distribution of our exponential distribution having parameter 1 upon theta. This can be written as 1 minus e raised to the power minus y into 1 upon theta, and hence this is our parameter for exponential distribution, which our option number B satisfies. Hence y, it reduces to y, which is the distribution function of exponential with the parameter 1 upon theta. So this was your question, and I hope that it is clear. It contained many of your parts, which included uniform distribution as well as distribution function, law, convergence in law, and a lot more. So the question that will be asked in exam will not only contain one topic, but it will be asked from multiple topics. So that was all for today. I hope that it is clear, and if not, then you can ask us in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best. Thank you.